Now we'll talk about slope. Whenever we graph a linear function, as it's implied by the name, the graph is just going to be a straight line. The steepness of this line is called the slope. So the larger the slope, the more steep the line is. That means that this line would have a larger slope than this line because it's steeper, and this line would have a larger slope than this line because it's steeper. Slopes that are close to zero are almost flat, and a slope that is zero will end up being completely horizontal when we graph it. There are two common ways to find the slope of a line. If we're given 2 points, x1, y1, and x2, y2, that are each on the graph of our function, then we can combine them using this formula here in order to find the slope m. Specifically, that's y2 minus y1 divided by x2 minus x1. We can see that we can actually write this as delta y over delta x, where delta just means change in, so change in y divided by change in x. And that's what gives us the mnemonic rise over run. How much the line is rising, or how much the y coordinate is changing, divided by how far it runs, how much the x coordinate is changing over that same period. So if we want to find the slope of the line that passes through the points 1, negative 4, that's x1, y1, and negative 3, 2, x2, y2, we can do so using the same formula, y2 minus y1 divided by x2 minus x1. Let's go ahead and plug these in. y2 is 2, and y1 is minus 4. x2 is negative 3, and x1 is 1. We've got to be careful of our minus signs here. 2 minus negative 4, that's the same thing as 2 plus 4 is 6, and negative 3 minus 1 is negative 4. We could simplify this as minus 3 over 2, or minus 1.5 if we wanted. Now keep in mind, if we had instead labeled these x2, y2, and x1, y1, although these numbers would be different, the final answer would turn out exactly the same, as long as we don't mix up. As long as our 2's are together and our 1's are together, then we should be good. So how do we find the slope of graphs on a line? Well, all we have to do is pick 2 points that are on our line. Let's start with this red one. I can see that this point here is 2 x coordinate, 5 y coordinate, and this point down here, still on the same line, looks like it is 0 for an x coordinate and minus 1 for a y coordinate. If we use that same formula, we'll write it at the top, y2 minus y1 divided by x2 minus x1, we should be able to calculate the slope. In this case, m equals 5 minus negative 1 divided by 2 minus 0, and we can see that this corresponds to 6 over 2, which is 3. What that means is that we're moving over 2 units, and we're moving up 6 units, and equivalently a slope of 3 means that each time I take a step 1 unit in the x direction, I go up 3 units in the y direction. Over 1, up 3, over 1, up 3. Let's try the blue line. Let's find 2 points on the blue line. This one seems pretty clear. That's 6, 4. And this one's pretty clear. That's 2, 2. Using the same formula, m equals y2 minus y1 divided by x2 minus x1. That's 2 over 4, or the same thing as 1/2. That means for every step I take in the x direction, we go up half a unit. We take another step, we go up another half a unit. Or if I take it 2 steps, we'll go up 1 whole unit. Lastly, let's look at this green line. Let's go with this point here. This looks like it's 8, -2. And maybe we'll go with the origin here, 0, 0. Notice it doesn't matter what order we do this in. In fact, I'm going to do it backwards, so to speak. I'm going to call this our y2, 0 minus -2, divided by 0 minus 8. That's going to give us, what's that, +2 over -8, which is -1/4. You would get the exact same answer if you did -2 minus 0 over 8 minus 0. In either case, a slope of -1/4. The negative means that we're slanted down as we go from left to right, and we go down 1/4 of a unit for each step in the x direction. Equivalently, that means if we go over 4 units, we'll go down 1. Go over another 4, down another 1. A slope of 1/4.